The vertebrate skull is a complex structure which evolved from three separate sets of components. The splanchno-cranium, or the gill arch skeleton, which evolved first, even dating back before vertebrates. The chondrocranium, the cartilaginous supports around the brain and sensory structures, which evolved in the early vertebrates, and the dermatocranium, made of dermal bone, which evolved in later fish. Bone in modern vertebrates can be formed in two separate ways. First, it can form from a cartilaginous model, as is typical in the appendicular skeleton, the arms and legs and girdles, where a cartilaginous model is converted to bone. In the skull, parts of the chondrocranium can be converted into bone in this way. However, the majority of the skull is formed through intermembranous ossification, a form of bone formation where connective tissue in a membrane, such as the dermis, simply differentiate to produce the osteoblasts, which start to make bone-making centers, or centers of ossification, which then expand. The earliest jawless fish only possessed cartilaginous skeletons and skulls, but by the end of the Cambrian, fragments found in the fossil record suggest that bone as a tissue had evolved, and by the Ordovician period, there were jawless fish which produced a bony head armor, a dermal skeleton, which protected their brain and sensory structures. Interestingly, not only did fish first evolve dermal bone in the skull and only later converted their cartilage of the appendicular skeleton to bone, in the human embryo, bone first exists as dermal bone forms in the skull, and later the cartilage of the appendicular skeleton is converted to bone. The jawless fish and the early jawed fish, such as placoderms, possessed heavy dermal armor composed typically of large plates of bone. Later fish, the acanthodians, transitional between cartilaginous fish and osteichthyan bony fish, evolved skulls that had small plates of dermal bone. By the late Silurian period, the earliest osteichthyan fish had evolved, which not only possessed small plates of dermal bone in their skulls, as did the acanthodians, but these now possessed recognizable structures. And so for the first time, it is possible to identify parietal bones and postparietal bones, and the components which would comprise parts of the mammalian temporal bone and occipital bone, etc. And so, from this point in osteichthyan evolution, one can trace the evolution of the dermatocranium with structures which would later compose the mammalian and human skulls.